this topic is about applying the binomial expansion to solve problems, including problems with unknown powers. So there's about 10 examples I'll go through. So listen as I go through each one. Okay, find the coefficient of x to the power of 4 in the binomial expansion of 2 plus 3x to the power of 10. So we're only looking at one term. So we only need to sort of magnify to that term and forget about everything else. Okay, so if I want x to the power of 4, it means I have to raise 3x to the power of 4. So the only way of getting that is 3x to the power of 4. But if I raise 3x to the power of 4, that means I need to raise 2 to the power of 10 take away 4, which is 6. So remember, the powers have to add up to n, which is 10. And then add the choose function at the beginning, which is 10, choose either 6 or 4. So just write 10, choose 4. Okay. So is equal to blah, 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 plus 10 choose 4 in your calculator is 210. 2 to the power of 6 is 64. And 3x all raised to the power of 4 is 81x to the power of 4. Which gives me 210 times 64 times 81 gives me 1088640 x to the power of 4. Which means the coefficient of x to the power of 4 is equal to just the number in front of x to the power of 4, which is 1088640. So that's part A done. Part B. Find the coefficient of x cubed in the binomial expansion of 2 plus x times 3 minus 2x to the power of 7. So the more complicated expression is 3 minus 2x to the power of 7. So let's expand that. Now we only need up to the x cubed term, so I only need to expand up to the x cubed term. Okay, now you might say, why am I not just expanding x cubed, just the x cubed term? Because remember, I still need to multiply by this 2 plus x. So I still need to multiply by that, so that's why I need to expand all the terms up to the x cubed. Okay, so if I expand 3 minus 2x to the power of 7 up to the x cubed term, I get 3 to the power of 7 plus 7 choose 1, 3 to the power of 6 times negative 2x plus 7 choose 2, 3 to the power of 5 times minus 2x all squared plus 7 choose 3, 3 to the power of 4 times minus 2x to the power of 3 plus dot dot dot. I don't care about any other terms. Which gives me in my calculator 2181. 7 choose 1 is just 7 times 3 to the power of 6 is 729 times negative 2x plus 7 choose 2 is 21 times 3 to the power of 5, which is 243 times negative 2x all squared is 4x squared. Plus the last term is 7 choose 3, which is 35 times 3 to the power of 4, which is 81 times negative 2x all cubed, which is minus 8x cubed. Now I just need to simplify each term. The first term is still 2181. The minus there because it's minus 2x. 7 times 729 times 2 gives me minus 10206x. The next term is going to be a plus. All I need to do is 21 times 243 times 4 in the calculator. So I get 20412 x squared. The next term is going to be subtract 35 times 81 times 8 gives me minus 22680 x to the power of 3 plus dot dot dot, which we're not interested in. We haven't fully answered the question yet. So if I want to do 2 plus x times 3 minus 2x to the power of 7, it's the same thing as 2 plus x times this expansion that I just worked out, which is 2181, take away 10206x plus 20412x squared minus 22680x cubed plus dot dot dot. Now the only way to make x cubed, so there's two different ways to make x cubed. If I do 2 times the negative 2680x cubed and x times 20412 x squared. That's the only two ways that I can get x cubed. So I'm just going to look at those two terms only. So it's equal to 2 times negative 22680 x cubed plus x times 20412 x squared. Dot, dot, dot. We don't care about anything else. So 2 times negative 22680 x cubed gives me minus 45360 x cubed plus 20412 x cubed. Dot, dot, dot. Which is equal to minus 24948 x cubed, which means the coefficient of x cubed is equal to negative 24948. Okay, let's try question 2, example 2 now. Write down the first three terms in ascending powers of x, the binomial expansion of 1 plus qx to the power of 8, where q is a non-zero constant. So first three ascending, so increasing powers of x. So 1 plus qx to the power of 8 is equal to 1 to the power of 8 plus 8 choose 1, 1 to the power of 7 times qx plus 8 choose 2, 1 to the power of 6 qx all squared. We don't care about the other terms. 1 to the power of 8 is just 1 plus 8 times 1 times qx. 8 choose 2 is 28 times 1 times q squared x squared. If we simplify each term, I get 1 plus 8qx plus 28q squared x squared plus dot dot dot. B. Given that in the expansion of 1 plus qx to the power of 8, the coefficient of x is minus r, so the coefficient of x is equal to minus r, and the coefficient of x squared is equal to 7r, find the value of q and the value of r. So what we do know is the coefficient of x is 8q, which means 8q is equal to minus r. That's one equation. And the coefficient of x squared is 28q squared. So we've got 28q squared is equal to 7r. Okay, if we simplify the second one, we get r is equal to 28q squared over 7. So r is equal to 4q squared. So we've got r is equal to 4q squared. And if I rearrange the second one, then I get r is also equal to negative 8q. So if I equate, so this is equation 1, equation 2, because r is the subject of both formulas, equating 1 and 2, I get 4q squared is equal to minus 8q, which implies 4q squared plus 8q is equal to 0. I factorize the 4q out, I get 4q times q plus 2 is equal to 0, which implies q is equal to 0 or q is equal to negative 2. Now we were told q is a non-zero constant at the start, so it can't be equal to 0, which means q is equal to negative 2. Now if q is equal to negative 2, don't forget we had equation 1, substitute into equation 1, then I get r is equal to minus 8q, which means minus 8 times minus 2, which is 16. So therefore r is equal to 16. Q is negative 2, r is equal to 16. Okay, let's go to the next question. It says find and simplify the first three terms in the expansion of 2 plus 5x to the power of 6 in ascending powers of x. So one is 2 plus 5x to the power of 6 is 2 to the power of 6 plus 6 choose 1, 2 to the power of 5 times 5x plus 6 choose 2, 2 to the power of 4 times 5x squared. So first three terms, those are three terms. 2 to the power of 6 is 64. 6 choose 1 is 6 times 2 to the power of 5 is 32 times 5x plus 6 choose 2 is 15. 2 to the power of 4 is 16 times 5x squared is 25x squared. So don't forget to square everything plus dot dot dot. Now all I need to do is simplify. First term is still 64. 6 times 32 times 5 gives me 960x plus 15 times 16 times 25 gives me 6000x squared. Says that's the first part done. Sorry, part 1 done. Part 2, in the expansion of 3 plus cx all squared times 2 plus 5x to the power of 6, which we've already worked out, the coefficient of x is 4416. Find the value of c. So the first thing I'm going to do is work out what 3 plus cx squared is. So if I expand it, I get 9. 2 times 3 is 9. 2 lots of 3 times cx, which is 6cx, plus cx all squared, which is c squared x squared. So when I'm doing 3 plus cx squared times 2 plus 5x to the power of 6, it's the same thing as doing 9 plus 6cx plus c squared x squared times the binomial expansion of 2 plus 5x, which is, I've already worked out, 64 plus 960x plus 6000x squared. Now, because we're only looking at the coefficient of x, that is enough. We don't need the other terms. So how can I get the coefficient of x from this? So I need to multiply 9 by 960x and 6cx by 64, because those are the only two possible ways I can get coefficients of x. So it's equal to, we don't care about the rest of it, 9 times 960x plus 6cx times 64, which is equal to 8640x plus 384cx. If I collect these together, it's the same thing as 8640 plus 384c times x. Now they say the coefficient of x is 4416. So I can equate this to 4416. So therefore, 8640 plus 384c is equal to 4416. So if I subtract 8640 from both sides, I end up getting negative 4224 on the right hand side. And the last step is if I do negative 4224 divided by 384, I get c is equal to negative 11. The next question. Find the first four terms in ascending powers of x or the binomial expansion of 1 plus ax to the power of 10, where a is a non-zero constant. Give each term in its simplest form. The first term will be 1 to the power of 10. Next term will be 10 choose 1, 1 to the power of 9 times ax plus 10 choose 2, 1 to the power of 8, ax all squared, plus 10 choose 3, 1 to the power of 7, ax cubed, plus dot dot dot. Now 1 to the power of anything is always 1, so I can have 1 plus 10 choose 1 is 10 times 1 times ax. 10 choose 2 is 45 times 1 times a squared x squared, plus 10 choose 3 is 120 times 1 times a cubed x cubed. If I simplify these terms, I get 1 plus 10ax plus 45a squared x squared plus 120a cubed x cubed. That's simplified. Each term has been simplified. Given that in this expansion, the coefficient of x cubed is double the coefficient of x squared. So if I had to write this as equation, this is where students get a bit muddled up. The coefficient of x cubed is double the coefficient of x squared. So I need to double the coefficient of x squared to get x cubed. So I need to write as 2 times coefficient of x squared gives me x cubed. So sometimes students make the mistake and write it the other way around. So please don't do that mistake. So the coefficient of x cubed is 120a cubed. So 120a cubed is equal to 2 times the coefficient of x squared, which is 45a squared. 2 times 45a squared. So that means I've got 120a cubed is equal to 2 times 45 is 90a squared. If I take everything to the left-hand side, I get 120a cubed minus 90a squared is equal to 0. If I divide through by 30, because it's a common factor of 30, I get 4a cubed minus 3a squared is equal to 0. If I factorize the a squared out, I get 4a minus 3 in the bracket, which implies a is equal to 0, but we were told a is a non-zero constant, so it can't be a is equal to 0, or a is equal to 3 over 4, which is the answer. Okay, the next example, find the binomial expansion of 2 plus x to the power of 5, simplifying the terms. Okay, say 2 plus x to the power of 5. So the first term is 2 to the highest power, which is to the power of 5. Next term would be 5, choose 1, 2 to the power of 4, times x to the power of 1, plus 5, choose 2, 2 to the power of 3, x to the power of 2, plus 5, choose 3, 2 to the power of 2, x to the power of 3, plus 5, choose 4, 2 to the power of 1, x to the power of 4, and the last term will be x raised to the power of 5. Okay, if we simplify this, 2 to the power of 5 is 32, 5 choose 1 is 5, times 2 to the power of 4 is 16, times x, plus 5 choose 2 is 10, times 2 cubed, which is 8, times x squared, plus 5 choose 3, which is 10, times 2 squared, which is 4, times x cubed, plus 5 times 2 times x to the power of 4, plus x to the power of 5. If we simplify this, we get 32 plus 5 times 16 is 80x, plus 10 times 8, which is 80x squared, plus 10 times 4 is 40x cubed, plus 5 times 2 is 10x to the power of 4, plus x to the power of 5. Okay, part 2. Hence find the coefficient of y cubed in the expansion of 2 plus 3y plus y squared to the power of 5. So in this expansion, this is x. Because it says hence, we have to use part 1 to help us solve this. So let x be equal to 3y plus y squared. And then 2 plus 3y plus y squared to the power of 5 is the same thing as 32 plus 80 times 3y plus y squared. So everywhere we see an x in the answer to part 1, we're replacing it with 3y plus y squared, plus 80 times 3y plus y squared to the power of 2, plus 40 times 3y plus y squared to the power of 3, plus 10 times 3y plus y squared to the power of 4, plus 3y plus y squared to the power of 5. Now we try to find the coefficient of y cubed. Now what we realize is the only term that would give us a y cubed term is from this term, you're going to get a y cubed, and for this term, you're going to get y cubed. So all other terms will not give you a coefficient of y cubed. So when we're looking at this, and we get lots of terms, but we're only zoning into the ones that give us coefficient of y cubed. Okay, so from that first one, so 80 times 3y plus y squared to the power of 2, the only way to get a coefficient of y cubed is 80 times, if we have to have 3y, and then we have to have to the power of 1, and we have to have y squared to the power of 1. And then we have to have the choose function of it. So how many ways of getting 3y and y squared? It's 2 choose 1. So that's how many combinations of y cubed we're going to get from that third term. Similarly, in the second one, you got second term, so the fourth term there, 40 times, the only way to get y cubed is 3y all cubed. And y, there's no y squared, so y squared to the power of 0 basically, and that is the combination involved with that is 3 choose 3 or 3 choose 0, same thing, plus dot dot dot. So that is the same thing as 80 times 2 times 3y times y squared plus 40 times 27y cubed times 1 times 1. Now if you again collect these like terms up, we get 80 times 2, 160, 160 times 3 is 480. And 40 times 27 gives you 1080 y cubed. So if you add this all up together, you get 1560 y cubed. Therefore, coefficient of y cubed is equal to 1560. Okay. In the binomial expansion, the ascending powers of x of 1 plus ax to the power of n, where a and n are constants, the coefficient of x is 9. The coefficient of x squared and x cubed are equal. Find the value of a and n. So first thing we do know is coefficient of x is equal to 9, and we know coefficient of x squared is equal to coefficient of x cubed. Okay, so let's expand 1 plus ax to the power of n up to the x cubed term, because that's all we need. So 1 plus ax to the power of n is equal to 1 to the power of n plus n choose 1, 1 to the power of n minus 1 times ax plus n choose 2, 1 to the power of n minus 2, ax all squared, plus n choose 3, 1 to the power of n minus 3 times ax cubed, plus dot dot dot. Okay, what we need to realize is we need to somehow, obviously, simplify this. So let's look at simplifying this. So n choose 1 is equal to n factorial over 1 factorial times n minus 1 factorial, which is the same thing as n times n minus 1 factorial over 1 times n minus 1 factorial. So these two cancel out. All I'm left with is n over 1, which is just n. In a similar way, if I do n choose 2, n choose 2 is equal to n factorial over 2 factorial times n minus 2 factorial, which is the same thing as n times n minus 1 times n minus 2 factorial over 2 times n minus 2 factorial. So then minus 2 factorial cancel out. All I'm left with is the n times n minus 1 over 2. And in a similar way, if I do n choose 3, it's the same thing as n factorial over 3 factorial n minus 3 factorial. which is n times n minus 1 times n minus 2 times n minus 3 factorial, all over 3 times 2 times 1 times n minus 3 factorial. If I cross it out, I'm left with n times n minus 1 times n minus 2 all over 3 times 2 times 1, which is 6. Okay, so let's simplify. Using this, let's simplify what we can. So 1 plus ax to the power of n. 1 to the power of n is just 1. N choose 1 is just n. 1 to the power of n minus 1 is just 1 again. And 1 to the power of anything is 1. So all I'm left with is n times ax. N choose 2 is n times n minus 1 over 2. 1 to the power of n minus 2 is just 1. And then we've got a squared x squared. And the last term is going to be n choose 3, which is n times n minus 1 times n minus 2 all over 6 a cubed x cubed, because 1 to the power of n minus 3 is still 1. So all I'm left with is a cubed x cubed plus dot dot dot. Let me just draw a line there so it doesn't get mixed up. Okay, so if the coefficient of x is equal to 9, coefficient of x is equal to 9 implies n times a is equal to 9. And we've got coefficient of x squared is equal to coefficient of x cubed. Then we end up with n times n minus 1 over 2 a squared is equal to n times n minus 1 times n minus 2 over 6 a cubed. So it looks like we need to simplify the second one. So if I simplify it, what I do end up noticing is n times n minus 1 can cancel out, n times n minus 1 can cancel out there. A squared can cancel out, and the a cubed goes to a. The 2 cancels out at the bottom, and the 6 divided by 2 is just 3. So all I'm left with is, this implies that 1 is equal to n minus 2 times a over 3. Which implies 3 is equal to NA minus 2A. But we already know what NA is equal to. So using, this is 1, we get 3 is equal to NA is just 9 minus 2A. Which means 2A is equal to 9 take away 3, which is 6. Which means A is equal to 6 divided by 2, which is 3. Now that we know A is equal to 3, using NA is equal to 9, we have 3n is equal to 9, which implies n is equal to 9 divided by 3, which is 3. Okay, next question. Write down the first 4 terms of the binomial expansion in ascending powers of x of 1 plus ax to the power of n. Okay, for n greater than 2. So 1 plus ax to the power of n is 1 to the power of n plus n choose 1, 1 to the power of n minus 1 of ax to the power of 1, plus n choose 2, 1 to the power of n minus 2, ax all squared, plus n choose 3, 1 to the power of n minus 3, ax all cubed, plus dot dot dot, which gives me 1 to the power of anything is 1, so I can simplify that. So we've got n choose 1 ax plus n choose 2, 1 to the power of n minus 2 is just 1, so a squared x squared, plus n choose 3, 1 to the power of n minus 3 is equal to 1, a cubed x cubed. Okay, now I know I've done this part in the last question, but in the exam we'd have to show the working out again. So let's work out n choose 1, n choose 2, and n choose 3 again. So if I wanted to work it out here, n choose 1 is equal to n factorial over 1 factorial n minus 1 factorial, which is equal to n times n minus 1 factorial over 1 factorial times n minus 1 factorial, which gives me n over 1 factorial, which is just n over 1, which is just n. So that means the first term is 1 plus nax. In a similar way, n choose 2 is equal to n factorial over 2 factorial n minus 2 factorial, which is equal to n times n minus 1 times n minus 2 factorial over 2 factorial times n minus 2 factorial. So they cancel out. All I'm left with is n times n minus 1 over 2 factorial is just 2 times 1, which is 2. So the second term, n choose 2, is n times n minus 1 over 2 a squared x squared. The last one, which is n choose 3. N choose 3 is equal to n factorial over 3 factorial n minus 3 factorial, which is n times n minus 1 times n minus 2 times n minus 3 factorial, all over 3 factorial n minus 3 factorial. So they cancel out. All I'm left with is n times n minus 1 times n minus 2. All over 3 factorial is 3 times 2 times 1, which is 6. So n choose 3 is n minus 1 times n minus 2 all over 6 a cubed x cubed. So that's a done. Given that in this expansion the coefficient of x is 8, so coefficient of x is equal to 8 implies na is equal to 8, or a is equal to 8 over n. Okay, and next thing is coefficient of x squared is equal to 30 implies n times n minus 1 over 2 a squared is equal to 30. Now if I rearrange this, this implies n times n minus 1 a squared is equal to 60. Okay, so using a is equal to 8 over n, I get n times n minus 1 times 8 over n squared is equal to 60. So the n here will cancel out with one of the n's, so I'm left with n minus 1 times 8 squared, which is 64 over n is equal to 60. Okay, so if I expand this, first time by n, so I get 64 times n minus 1 is equal to 60n. If I expand it, I get 64n minus 64 is equal to 60n. If I take n's to one side, I end up getting 64 and take away 6n, which is 4n. 4n is equal to 64, which means n is equal to 64 divided by 4, which is 16. If n is equal to 16, so n is equal to 16. So since a is equal to 8 over n, a is equal to 8 over 16, which means a is equal to a half. So n equals 16, a is equal to a half. The last step is find the coefficient of x cubed. So c is coefficient of x cubed is equal to n times n minus 1 times n minus 2 over 6 a cubed, which is equal to 16 times 16 take away 1 times 16 take away 2 all over 6 times half cubed, which is 16 times 15 times 14 divided by 6 times by half cubed, which is 1 over 8. So the 8 cancels out with the 8 there, 2. The 6 cancels out with the 2 times 3 here, so it becomes 5. So all I'm left with is 5 times 14, which is 70. Okay, the next question. The first three terms in the expansion ascending power of x of 1 plus px to the power of n are 1 minus 18x plus 36p squared x squared. Given that n is a positive integer, find the value of n and the value of p. Okay, so if I expand first, 1 plus px to the power of n is 1 to the power of n plus n choose 1, 1 to the power of n minus 1, px, plus n choose 2, 1 to the power of n minus 2, px all squared, plus dot dot dot, which is equal to 1 plus n choose 1 is just n factorial over 1 factorial n minus 1 factorial. 1 to the power of n minus 1 is just 1 times by px, plus n choose 2 is n factorial over 2 factorial n minus 2 factorial. 1 to the power of n minus 2 is just 1 times by p squared x squared. It's the same thing as 1 plus n factorial over 1 factorial. Actually, let's not do that. N times n minus 1 factorial over n minus 1 factorial, which will cancel out. And the second term will give me n times n minus 1 times n minus 2 factorial all over 2 factorial times n minus 2 factorial. So n minus 2 factorial will cancel out. P squared x squared plus dot dot dot. If I simplify further, I get 1 plus n times n over 1 factorial is just n over 1, which is n, px, plus the second term is, so the third term is going to be n times n minus 1 over 2 factorial, which is just 2 p squared x squared. So what we do know is coefficient of x is equal to minus 18 from here, which implies np is equal to minus 18. And coefficient of x squared is equal to 36p squared, which implies n times n minus 1 over 2 p squared is equal to 36p squared, which implies n times n minus 1 over 2 is equal to 36, which means n times n minus 1 is equal to 72, which means n squared minus n, if I take the 72 over to the other side, I get minus 72 is equal to 0. If I factorize this, I get n minus 9, n plus 8 is equal to 0, which means n is equal to 9 or n is equal to negative 8. Now n can't be negative 8 as it is a positive number, so therefore n is equal to 9. Since n times p is equal to minus 18, 9 times, that means 9 times p is equal to minus 18, which implies p is equal to minus 18 divided by 9, which is negative 2. Next question. The first four terms in ascending powers of x of the binomial expansion of 1 plus kx to the power of n are 1 plus ax plus bx squared plus bx cubed, where k is a positive constant and a, b, n are positive integers. By considering the coefficient of x squared and x cubed, show that 3 is equal to n minus 1, n minus 2 times k. So I need to expand 1 plus kx to the power of n for the first four terms. So I get 1 to the power of n plus n choose 1, 1 to the power of n minus 1 times kx plus n choose 2, 1 to the power of n minus 2 kx all squared plus n choose 2, 3, n choose 3, 1 to the power of n minus 3 kx all cubed. The first term, 1 to the power of anything is 1. N choose 1 is n factorial over 1 factorial n minus 1 factorial. 1 to the power of anything is just 1 times kx. N choose 2 is n factorial over 2 factorial n minus 2 factorial. 1 to the power of n minus 2 is just 1 times k squared x squared. Plus n choose 3 is n factorial over 3 factorial n minus 3 factorial times 1 times k cubed x cubed. Okay, and to simplify this, so it becomes 1 plus n times n minus 1 factorial over 1 times n minus 1 factorial. So they will cancel out, times kx plus n times n minus 1 times n minus 2 factorial over 2 factorial n minus 2 factorial. So they will cancel out, times k squared x squared plus n times n minus 1 times n minus 2 times n minus 3 factorial over 3 factorial n minus 3 factorial, which will cancel out, k cubed x cubed. Okay, which simplifies to n over 1 is just n, so nkx, plus n times n minus 1 over 2 factorial is n times n minus 1 over 2, k squared x squared, plus the last term is going to be n times n minus 1 times n minus 2 over 3 factorial, which is 6, k cubed x cubed. Now what we do know is, if you look at this, the coefficient of x squared is equal to the coefficient of x cubed. So coefficient of x squared is equal to coefficient of x cubed, which implies n times n minus 1 over 2 k squared is equal to n times n minus 1 times n minus 2 over 6k cubed. So let's see what we can cancel that. The n minus 1, definitely. The k squared with the k squared here, so all we're left with is k cubed divided by k squared, which is just k. And the last thing is you can divide by 2 here. If you do 6 divided by 2, it's 3. So what you end up with is, there's nothing left over in the left-hand side, so there's an invisible 1 there. And n minus 2 times k over 3. So if I multiply both sides by 3, I end up getting 3 is equal to n minus 2 times k, which is what we wanted to show. B, given that a is equal to 4, find the value of n and the value of k. So if a is equal to 4, because a is the coefficient of x, that means nk is equal to 4. Okay, so nk is equal to 4, which implies, if I replace, okay, I'll replace, okay, so nk is equal to 4. So what happens with, we have 3 is equal to n minus 2 times k in the first part of the question, which if I expand, I get 3 is equal to kn minus 2k, but we've just known that nk is equal to 4. So using nk is equal to 4, that means 3 is equal to 4 minus 2k, which means 2k is equal to 4 take away 3, which is 1, which means k is equal to a half. Now if k is equal to a half, using nk is equal to 4, we got n times a half is equal to 4, which means n over 2 is equal to 4, which means n is equal to 4 times 2, which is equal to 8. Okay, the last question I'll go through. The coefficient of x squared is 3 times the coefficient of x cubed in 3 plus kx to the power of 7. Find the value of k, and k is not equal to 0. Okay, so 3 plus kx to the power of 7. So I need to go up to the x cubed term. Well, I actually just need the x squared term and the x cubed term. So that means I need to have kx to the power of 2, which means I get 3 to the power of the complement of 2, which is 5, because the powers have to add up to 7. And that means it's going to be 7 choose 2 ways of combining these two terms. And the second term that I need is the x cubed term, which means I have to raise kx to the power of 3, which means 3 has to be raised to 4, and it's 7 choose 3. Okay, so we're ignoring everything else except for the x squared and the x cubed term. 7 choose 2 is 21. 3 to the power of 5 is 243 times k squared x squared, plus 7 choose 3 is 35 times 3 to the power of 4 is 81 times k cubed x cubed. If I simplify this, I get 5103 k squared x squared plus 2835 k cubed x cubed. Okay, so we have the coefficient of x squared is equal to 3 times the coefficient of x cubed, which means 5103 k squared is equal to 3 times 2835 k cubed. If we divide by k squared, we're allowed to do that because k is not equal to 0. So then we get 5103 is equal to 8505 k, which means k must be equal to 5103 divided by 8505, which gives us 0.6. So k is equal to 0.6.